What's going on, Algebra 1? Even though I'm not there today, you're going to watch this awesome screencast, and I'm going to teach to you just a little bit of new material. We're going to just review really quickly since it's been the weekend. I hope you had a great weekend. We're going to review super quick about exponential functions and then jump into some compound interest and half-life. Um, so creepily, you're like watching me in my home, so you're kind of here but not here. Um, I just first want to apologize for two mistakes I made. I should have never given you guys that extra class practice for homework over the weekend because there was just some stuff you couldn't do on there. And you guys already had homework, so putting that on top of it was a little bit difficult. So we're going to actually return back to that in class today. You're going to learn how to do the other stuff that's on there. And if you did try, thanks for trying. If you didn't, or even if you did, just we're going to go back and fix it because now you know how to do the compound interest and half-life stuff. Also, that's mistake number one. Mistake number two is I'm grading your test right now, and I realized everyone is missing a page. So I must have copied without including a page. I don't know how. None of you guys catch on that. Come on. But that's okay. So tomorrow, plan on Tuesday, we're gonna take that other part of that test. I'm just gonna call it test part two. So make sure you review some probability stuff just so you have a reminder, even though it's been a couple days, just make sure you remind yourself of kind of what we did during that probability unit since it was a couple days back during last week, but we'll be all right. It'll help everyone's grade. So we're looking at day 2 of exponential functions. Remember the general form of an exponential function is y equals a times b to the x. You can get on the next slide as well. So anytime during the video you need to pause, anything like that, feel free to pause. That's the nice thing about doing a video of me. You can kind of go at your own speed. You should be filling out the first purple sheet. I'm going to expect you to glue it into your interactive notebook, cut it out, and glue it after you're done taking all the notes. So, general form, y equals a times b to the x. Today we're going to look at the first part of this video. We're going to look at how a and b affect the general form, the way it looks on your graph. So let's kind of dive right into that. We're going to look at 4 different things. So you're going to fill in the what happens to the graph as b increases, and then you're just going to keep following along with that. So the first one, obviously, we're looking at when b increases. Everyone that's watching, just please take a moment to look at this. And so when we do all these, just take a moment, pause it if you need to. Just try to make your own assumptions of what you think is happening. So 2, 5, 15, b is increasing. Let's see what happens. So hopefully you've noticed that the steepness of these lines increased as b increased. So 2 squared is 4, 5 squared is 25, and 15 squared, we're already up almost at 200. So we're getting up there pretty quickly. So just as b increases, the slope of the line, you can say the slope, or you can say the rate of the line is increasing, anything like that. Now we're going to look at when b is between 0 and 1. So we're looking at some type of fraction or decimal between 0 and 1. Again, just like last time, take a quick look at it. So here we can see that we have, instead of growth, we have decay. So as we go towards infinity and the x's, the y's are getting closer and closer to 0. You can see that if it's closer to 1, we have a little bit gradual, but when it's close to 0, we're getting there really quick. So now we have flipped over. So remember, increase looked like this. Now we flipped it over the y-axis, and now we have decay. So now that we've looked at both the types of b's, let's look at an a value and see what that does to it. So we have 1, 5, and 10. The base is all the same here. The base is 3. But our initial value is changing. See if you can see anything that's happening. So if you look on the y-axis, it's actually the same value as the initial. And why would that make sense? Well, if we plug in 1, if we plug in 0 for x, that's going to make this 1. So 10 times 1 is just 10. So remember the y-axis is when x is 0. So that's just going to be our initial value. So it's either shifting it up, or let's see what happens when it's negative. So if we look at the negative, now the whole graph has been reflected over the x, so we have a nice as it goes positive this way, if it goes towards infinity and the x's, we're going to negative infinity now. And again, that y-intercept is still what that a value is. Negative 10, negative 5. Pretty easy. So you should have filled out that first table. It's a quick review of what we did last time, just looking more at the graph. Again, if you ever forget any of that, you could just plug in a table of values and figure out all those answers. So now we're going to look at compound interest. Here's the formula. You're definitely going to have to pause it here because I'm going to move through that quickly because I want to get to some examples. But you should also label all these. So this is the amount in the account. This is our principal or our initial, what we're starting with, what we're investing. Our rate of interest. So what's our interest rate? Remember, this will be as a decimal, not as a percent, but it will most likely be given to you as a percent because you have a percent interest. I'm getting 5% interest, 10% interest. When you plug it in, it has to be a decimal. And then number of times per year, we'll get into what this looks like and what this looks like. So, different times per year. These are the words you're going to see: annually, semi-annually, quarterly, monthly, and weekly. I think for most people, they know this already, but it's never bad to go over it. So annual means it's just going to be compounded once. So that interest is going to be affected on your money only once while it's in the bank account. Or same with your car. If you're losing interest on your car or your interest on a loan, it's only going to happen once a year. The interest is going to be applied. Semi-annually is twice, quarterly is 4 times, monthly is 12 times, and 52 times for weekly. This is what n is going to be for all those different times. I'm going to move on, so if you need to pause, go ahead. Let's go over this first example. I've already underlined kind of the important information in this. So suppose you have $1,050 at an annual interest rate of 5.5%, and it's compounded semi-annually. So that means our n is going to be 2. How much money to the nearest dollar will you have in your account after 5 years? So the nice thing with compound interest is you just follow this formula. A, the amount in your account, equals our P. Well, P here is 1,050 because that's our initial, that's our principal. Times 1 plus our R. Remember, our R is this rate, but it can't be a percentage. It has to be a decimal, so it's 0.055. If you forget how to get there, well, it's bad 5. If you forget how to get there, you can either divide our percentage by 100, which is the same thing as just moving the decimal place twice to the left. So you get 0.055. All over our n, in this case semi-annually, which is 2. And then it's times 2 to the t, which here is 5. It's 5 years. It's the number of years. So you plug this in the calculator. Be careful with your parentheses. Again, personally, I do it step by step. But once you plug it in, you should get 1,377. $1,377. So if you left this money in the account for 5 years at this rate and this money compounds, you'd only gain about $300. Not bad. Not super great either. So now I want you to pause the video. I want you to take some time to do this problem on your own. For the examples, guys, make sure you write down the whole thing. I didn't type it in there, but I left you plenty of room to write it down. So make sure you write down the example, because when you go back into your notes for help, you're going to have no idea and you're not going to have these slides. So make sure you write it down. You invest $1,300 at an annual interest rate of 4.3% and compounded quarterly. Find the amount you will have in 3 years. So pause the video now, take some time to try this on your own, and then come on back and I'll show you the answer. All right, welcome back. So for an answer, you should have got A. That's a terrible A, but it's okay. I'm really trying my hardest to write with a cursor. So 1,477.78 if you round it up. But that's how much money we have now. We gained about $177 in 3 years, which isn't that bad. So those are your only 2 examples on compound interest. Now for the last 5 minutes of the video, we're going to spend some time talking about half-life. So this is where chemistry and math really have a nice overlap. So half-life means we have some type of element or some type of atom, and we have a certain amount of it. And the half-life, so it's decaying, it's dying, it's just breaking apart. So the half-life means we're losing half of it every certain numbers of days. So each element has its own half-life. So here we're going to be looking at phosphorus, 32. And its half-life is going to be 14.3 days. If you want some more information on half-life and what it entails, more than free to Google it right now. But I'm not going to really get into that much. I want to look more at the math side. That would be more of your chemistry teacher. So half-life is 14.3 days. We have that much of the sample. Find how much phosphorus 32 is remaining after 84 days. So if the half-life is 14.3 days, that means we'll have 25 milligrams after 14.3 days. But we want to look at 84 days. So we're using our same general form, a times b to the x, but now we have to plug in some stuff. So our base is always going to be a half when we're looking at half-life. Later we'll get into double life, and that'll be 2 for the base, but our half-life is always going to be half for the base. Our initial, how much of the sample we're starting with, goes in as our A, 50. This is the tricky part right here, our rate. Our rate is always 1 over the number of days times x. So how many days? 84. So you need to plug in 84 for x. And when you plug in 84 for x, you get y equals 0.85 milligrams. Oh, I forgot the 5. Try that again. 0.85 milligrams. Again, be really careful plugging into your calculator because you can definitely mess this up if you don't use parentheses correctly. So what that means is in 84 days, we'll go from 50 milligrams to 0.85. Pretty crazy. So you have 2 more examples to do. I will show you the first one. You'll go and try that. You'll come back here. You'll pause it. Then you'll come back here and you'll see the answer. Then I'll give you the third one. Again, same thing. And then you'll go on to do some other stuff. So if you didn't pause the video, make sure you do it now because I'm about to reveal the answer. So the answer should be y equals 34.6 milligrams. Now, the nice thing with half-life is it's very realistic, so you can kind of look at your answer and see if it makes sense. This answer, 34.6, makes sense. And why? Well, look at the half-life is 13.2 hours. We only want to know how much is going to be left after 5. So, if we got an answer that was less than half of this, we would have did something wrong. So, half of 45, I think, is about 27 something, 27.5. Yeah, 27.5. No, that's not right. 22. Geez, my mental math is off. 22.5. So this is greater than 22.5, so that makes sense. Sorry for that mental math there. Whoa. Oh, we somehow ended up in other slides. That's fine. So now let's look at the next example. The half-life of barium-137 is 2.552 minutes. How much of an 18-gram sample, now we're in grams instead of milligrams, 18-gram sample will be left after 10 minutes. So it's definitely going to be less than 9. So go ahead and try it on your own. So by now, you make sure you've paused it because I'm going to go over the answer really soon. So here we go. Let's go over this one. Again, this is our rate. Remember, our rate is 1 over 2.552. And so when we plug it in all, we should get our answer is 1.19 grams. That's what should be left. after 10 minutes. The half life of